I have the pleasure to dive once again into a set of Spring Framework 5 related topics. This time a little differently than in yesterday morning's keynote. It's kind of meant as a complimentary session. In this particular one, we're not really talking about the JDKs much at all. It's more about component model style, it's about reactive architectures, it's about the many little things that we managed to refine in Spring Framework 5, and there are quite a few things in there that we don't talk about much at all, for better or for worse. So there might be a few things in there that you haven't read about or heard about at all in any other article. Right, so I have, of course, a very personal relationship with this effort since in my 15-year quest. I'm also, as with every Spring Framework generation, I have the responsibility for what turned into Spring Framework 5 and also for the ongoing evolution. We are actually currently embarking towards Spring Framework 5.1, which has literally started the branch a few days ago after the 5.05 release. What I'm going to talk about today is largely Spring Framework 5.0, state of affairs, with a few hints towards 5.1. We have the same kind of roadmap again that we had in the Spring Framework 4 generation. If you remember, there was Spring Framework 4.0 as kind of the kickoff of this generation, and there was a 4.1 release, a 4.2 release, a 4.3 release, very rich feature releases coming roughly every 9 to 10 months after each other. This is going to be the same here. So we expect 5.1 to go final somewhere between late July and early September. We'll get to that again towards the very end. So for today's purposes, let's talk about the state that we're in. This is the fact sheet again, kind of, but I'd like to focus on a few different things. So we're currently in 5.05, which is already a pretty refined state of affairs with lots of feedback incorporated, lots of actually performance tuning, that sort of stuff that happened in the meantime on a few of the new features. Just summarizing a few very important points. Aside from the Java 8 baseline, we're also raising the infrastructure baseline in other places. So it requires a Servlet 3.1 or higher container. We'll get back to that a little bit later, why that really goes nicely with some of the things we're doing here. So there's a few minimum requirements raised, but there's of course also integration with the current level of infrastructure out there. So in the JDK world, that would be JDK 9 and 10. But here in Java EE integration, it is the Java EE 8 level of APIs and the corresponding servers and containers. So most importantly, Tomcat 9, because at Pivotal in the Java group that the Spring open source team lives within, we also have 3 dedicated Tomcat committers. So Tomcat is in many ways actually very close to us and largely run by that group, the Apache Tomcat project. But of course there's the Hibernate Validator 6, for example, as a bean validation 2 provider, or in terms of the new JSON binding API in Java EE8, we support the Eclipse Yeson and Apache Johnson, primarily Johnson for testing on our end, as providers for the JSON binding APIs, an alternative to Google JSON and to Jackson for JSON binding. So there's quite a bit of stuff that we do in that space in terms of integration with basically other infrastructure, right, out there, both servers and other providers, other libraries. We do everything we can to be on top of the curve there. We're currently tracking JPA 2.2 in terms of Hibernate 5.3. Hibernate 5.3 is not final yet, so some of those specifications actually don't have too many providers at this point. Some of this is going to be wrapped up in the next few months, and we're going to pick it up in our Spring Framework 5.1 release. All right, the most important factors in Spring Framework 5 were actually design factors. The component model design, a functional style in particular, and the impact of reactive architectures on a typical on the typical Spring stack. So let's dive into the component style first, because this is this is actually from my perspective, the most important part for a start. We traditionally focus on annotations, right? Everybody, I suppose most of you have seen the annotation style. Who's actively using Spring while we're at it? Active Spring users? All right, yeah, I figured it would be quite a few of you. So you've seen this, right? The annotation-based components are basically what you know from the Spring Framework 3 and 4 generations in particular. Spring Framework 4 had a very strong focus on refining the annotation-based component model. Many of the things we did in 4.1, in 4.2, in 4.3 were towards that goal, fine-tuning the component model, completing the annotation-based component model. So the typical annotation-based component, we don't really need to dive into it too much, but you see its traditional style, stereotype annotation, auto-wiring annotations, which, by the way, as of 4.3, isn't actually mandatory anymore. If there's just a single constructor in an otherwise clearly designed component, then we use that constructor even if it's not annotated. It's particularly useful if there are no other annotations in that component. But anyway, the transactional annotation is the typical marker for service-level methods to wrap them in a runtime transaction, right? So essentially, a demarcation of certain elements, an enrichment in semantics for particular source code elements. We are using annotations to illustrate certain characteristics that we cannot express in the Java language itself. I mean, this is, of course, a very comprehensive affair, and we're only seeing a few of those annotations in use here. But in the end, it follows a certain design language that we've really elaborated on for many years. You know, like my book admin service is a lazy service class, very readable if you jump around a bit. This is an auto-wired constructor. This is a transactional method. So we're really trying to keep up the Java language design. The Java language itself is quite readable in its English incarnation, right? So we try to follow that language to fit the annotation names into that language. Anyway, this is essentially where Spring Framework 4.3 is at. A strong focus we had, and that we actually fine-tuned quite a bit lately, and that still plays a very central role in Spring Framework 5, is the composable annotation model. Plenty of use of this, even if you might not be aware of it. But you could, like in this particular case, even design your own. Very important point, Spring's annotation-based component model is extensible. It's not meant to be a sealed-off fixed version that you're using the way some PDF document says. It's a very live affair. We refine it every year. You may refine it every year by using some of its extension mechanisms, and this is one of them. Building a custom annotation, declaring the custom annotation on classes of yours, and combining certain semantics, in this case, out-of-the-box semantics from other Spring annotations onto one simple, finely named shortcut, right? In practice, of course, don't call it my service, give it a proper name with a meaning in the context of your code base, within the context of your architecture. But this is also something we focused on. Extension mechanisms, the annotation-based model is really a wide and deep affair in the meantime. All right, configuration classes you, of course, know, in particular from Spring Bootland, but it's actually a core container mechanism in Spring Framework itself. The mechanisms are in place for many years. They've been introduced in Spring Framework 3, fine-tuned in 3.1, in particular in the 4 generation, and actually performance-tuned even very recently. So basically, part of the wider component model configuration class is building other components through annotated factory methods. But again, annotations, of course, indicating the points that the container needs to understand. So for construction purposes, you're nowhere pointing to this method. The container finds the method through introspection. It introspects all the registered component classes. It finds the annotations on the methods, on the type, and on the methods of those component classes. It needs to go through the process in order to understand how to use and how to call those annotated components. In order to arrive at the initial set of component classes, you might use a component scan, like a scan through the class path, finding all the classes with certain annotations at the type level. So for the component scan, these annotations here, the stereotypes, are essentially the indicator, the marker that we use to find them in the class path. But that's a totally optional rule, right? Standard component scans. You can also enumerate the components. Annotation, config, application, context, register, this class, that class, yet another class. Just enumerate the classes. Which is a straightforward replacement for a component scan, saving the diving into the class loader and trying to find all the candidate classes. Right, so there are already many ways how to go about this, but it sort of really goes nicely together with component scanning and with runtime introspection. Last but not least, in this little warm-up and review, the annotated controller model, which we're actually going to kind of rediscover in just a few minutes in its WebFlux incarnation. This is meant to be a regular Spring MVC controller being run behind the dispatcher servlet, invoked within the regular servlet invocation model with a thread attached to every single incoming request, and with blocking reads and blocking writes from the request into the response respectively. In terms of design, this kind of control, of course, follows the same general conventions, right? A type level stereotype, this is a controller, or in this particular case, a REST controller with more specific semantics. Other annotations like laziness is also expressed here, like the cross-origin opening is expressed at the type level as a characteristic for the entire controller, and the specific mappings happen at the method level, just like configuration classes, right? At bean methods at the method level. And once again, we understand them by going through all the register component classes, understanding which ones have a controller annotation or a variant thereof. This one is meta-annotated with standard add controller. We go through all the methods if necessary, we find the mappings and we register the mappings. Again, it's runtime introspection, finding annotations to call on methods that we need to call whenever a request comes in this particular case. And how do we extract information from those, design-wise? Right, we use flexible method signatures. And in those flexible method signatures, we use parameter annotations. So we annotate a specific parameter. Several parameters may each have their own annotations. So in this case, just long ID doesn't really say much, right? But the long ID is a path variable, needs to be extracted from the path where a variable of the same name has to be demarcated, right? There's at request parameter, at request header, at cookie value. There's many other parameter level annotations. Flexible signatures with parameter level annotations in order to extract information from the incoming request. We're going to revisit that. All right, many other things to say, but just one last note here. These annotations are actually reasonably recent. They date back to Spring Framework 4.3, and are just convenience annotations that you could also build yourself. They are meta-annotated. They are basically annotations that we ship that have at-request mapping on themselves. So they're just variants of standard at-request mapping, but following a specific design language and a specific design compromise, we wanted to bake the HTTP method into the annotation name so that for simple purposes, you would only specify a single attribute, the path, and the Java annotation model allows for shortening that value. You don't need to say path equals or value equals. You can just specify the value and reduce the size of simple mappings significantly. And it also reads nicely, and it was a common request. We actually had quite a few people knocking on our door for those. So get mapping and post mapping, patch mapping, and so forth, basically just specific variants of Spring's at-request mapping annotation. And they are also going to reappear in the WebFlux world, in its reactive cousin or brother of that model. Right, so let me elaborate a little on the idea behind taking a different perspective here. These annotation-based components are, of course, really well established already. And we're fine-tuning it. Even in Spring Framework 5, there's minor fine-tuning, a few extra attributes in a few places, in some of the more specialized annotations. But as a major release, at the opportunity of a major Spring Framework release, we chose to revisit our core container architecture and our programming model overall from a very different perspective. Just for the fun of it, right? Now, just for the tension of it, for forcing us to see things differently and forcing us to re-understand our core container design decisions. So we continued a very well-established annotation-based component model. That story is nowhere near the end of its line. It's still the mainstream model, of course, and will continue to be for the foreseeable future, although that's not actually our call, that's your call, because things or component models, variants of component models, can only become mainstream if they see very broad adoption, and adoption is your call, not ours. We just provide the variants. All right, so we chose to have a functional design focus. We basically said, like, here's a pretty complete annotation-based component model on one end. What if we instructed our core container, and not just the core container, but other core facilities, even the core web infrastructure, in a programmatic way, but in a Java 8-based programmatic way, with strong use of Java 8's functional API style and functional language features. So APIs that are designed in a more fluent way and geared towards method references, towards Lambda expressions, towards the use of the Java util function package. This design perspective is somewhat extreme because we really mean it, right? In a totally programmatic setup, more functionally styled, but in particular programmatic setup, there is no annotation introspection. There is no class path scanning. In its extreme incarnation, there is not even reflection. So we meant to come up with a variant of using those core facilities without any use of reflection or without any annotation introspection, without any class path scanning, although that was possible, easily possible before. Okay, this is a bit of an extreme perspective, right? See it as kind of an extreme end of a spectrum, like very black and white. We, of course, understand that in practice, everything's gray, right? Different shades of gray. Features are being combined. So, of course, these new variants can be combined with annotation-based transactions, with annotation-based, even with annotation-based injection. There are many ways of combining the annotation-based features and the functional style features. Now, we're going to see this in just a moment, what this looked like in terms of source code, but one important note. We focus on Java 8 as the mainstream language, of course, and its kind of functional incarnation, the functional style that it introduced. But at the same time, we chose to have Kotlin as an equally first-class candidate. Not as mainstream, at least not at the point when we chose it. It actually became significantly more popular in the meantime. So what if basically you were to write a Spring application, a fully Spring Stack-based service in the Kotlin language, or at least partially in the Kotlin language, but actually for our purposes entirely in the Kotlin language, without any use of the Java language, but calling into the same core container APIs, in the same registration APIs for web endpoints. This was a quite interesting exercise initially, but we quickly found out that there's a lot of potential in this, that the Kotlin language actually provides some really nice facilities, not just the language, but also Kotlin's runtime introspection APIs for method signatures in particular, or for function signatures. So we started rolling out Kotlin extensions. Many of the core Spring APIs and even the core implementation classes for some of the registration facilities have Kotlin extensions living next to them, where additional methods, essentially overloaded methods, particularly geared towards using Kotlin, doing things the Kotlin way in a very intuitive, very original Kotlin style. And in particular, making use of some of the Kotlin facilities, like why repeat a component class if a Kotlin function clearly knows which return type it has, which Java 8 Lambda expression doesn't. So we're also making use of some Kotlin specifics in order to provide a more concise, less repeat yourself syntax. All right, let's illustrate this by example. And I'll just focus on very core examples for the time being to illustrate a few points. This, I have actually been showing this yesterday as well, but let's discuss it in a bit more detail. This is a standard generic application context. Has been around for 10 years in Spring, easily 10 years. But it comes with new methods now. Register bean methods, simple overloaded methods, allowing to register beans in a programmatic way, making use of Java 8 language features in this incarnation. We'll see the Kotlin incarnation next. So in this one, we register two classes, basically, two components. Bean definitions resulting from those, essentially the same as if you had foo class and bar class on your class path, annotated with a stereotype and found through a component scan, right? Same purpose. If you only specify the component class, like here, foo.class, then you would rely on default assumptions for everything else. So default constructor to be used, or whatever, right? Standard introspection rules, actually quite customizable, but the standard rules really work quite well. So if you wanted to be a bit more specific, and in particular a bit more custom, if you wanted to do things that you would otherwise do in a configuration class with an add-bean method, like some custom construction rules. Maybe you want to use a builder API. Maybe you need to call some other lookup API in order to arrive at an instance. Or maybe you just want to build an instance and populate it a bit before returning it, right? Stuff that you usually do in a factory method. But here, it's not a factory method. It's what we call an instance supplier. So this register bean variant says we are here kind of defining the component of type bar, creating a bean definition for a bean of type bar. And whenever the container needs a new instance of bar, it will dispatch straight to the specified instance supplier. Instance supplier is a Java util function supplier, so a Java 8 supplier. But in this case, of course, not implemented as a supplier interface implementation, but as an inline Lambda expression. Could also be, of course, a Java 8 method reference, if you had a method that you could easily adapt here. And then, of course, you're very close to factory methods again, but no annotations involved, right? But here it's even inline, no external method. And whenever the container needs a new instance means the life cycle of the component is still up to the container. Same rules apply as with all other bean definitions, with all other kinds of beans. The container is in charge of, first, having them registered, creating them as needed according to their scope, and shutting them down whenever they are out of scope, right? So if in the default singleton scope, this method will usually only be invoked once. But it's still the container deciding when to invoke it. For example, for a lazy component or for a larger component graph with interdependencies, it's still up to the container when exactly to call it. You're not actually constructing it at that point. You're just providing a callback for constructing it whenever the container decides to need a new instance. When the scope is different, so whenever you need a prototype scope bean or a session scoped bean, of course, the instance supply makes even more sense. It's called for every fresh instance of the bean in a new session, for example. So the example below is a variation of the above, and there are some subtle differences that really illustrate important points. First of all, we have an extended version of the bar registration, not just specifying an instance supplier, Lambda expression here, but another Lambda expression, which we call bean definition customizers. There can be any number of those. It's a var arg. And bean definition customizers allow you to go down to the bean definition model that the core container always had. Bean definitions are essentially a 15-year-old API. The bean definitions have all the metadata that Spring supports in addition to the component class itself, right? So anything that the component class itself, like bar.class, doesn't express. So you may add, for example, lazy init flags, string-based qualifiers. You may add attributes that post-processors can introspect. There are many things you can do at that level, anything that the bean definition API allows for. So in this case, a very common example, switching it to lazy init, keeping the default scope singleton, but switching it to a lazy init singleton. Whenever first needed, the container will trigger its construction, just like the @lazy init annotation on the previously seen annotated service component. Now, what about this one? This is a little extra subtlety, a favorite of mine, not because it's so important, but because it illustrates a nice point. So why a method reference here? What kind of method reference is this? This is a Java 8 method reference to the default constructor of the class foo. Now, wouldn't we call the default constructor up here as well? Of course we do, by default, according to the default conventions. But we have to use reflection. Essentially, we do class new instance here. We don't actually do class new instance because that's deprecated on JDK 9, but we essentially find the default constructor and create a new instance with it. That is reflection. We go through the reflection APIs. There's a reflection overhead here. In this version below, in this variant below here, we are dispatching to the default constructor through a Java 8 method reference passed in as an instance supplier. At runtime, this is a straightforward method dispatch. It's an invoke dynamic dispatch straight to the constructor. There is no reflection involved. So if you wanted a completely reflection-free setup for an application context in a particular microservice, this is how to arrive at it. Now, take it with a big grain of salt. That reflection really doesn't make a difference in most cases, in particular not for singletons. Maybe for highly, for prototype beans highly used in many scenarios with many instances created, maybe, right? It's more important to understand that reflection only comes in if you want it to. There's no hidden reflection. There's always a way to be very specific about what should actually happen at a particular point of time. All right, even more variants here, right? Two more variants, this time not in Java, but in Kotlin. The version above, I'm dubbing the Java-style version of it, my own words, and this is the Gradle-style version of it, not an official name, just kind of mimicking the Gradle, the build system, right? Gradle's Kotlin DSL has a kind of similar style. That's why I'm calling it Gradle style. So the version above is quite close to the Java version, right? It's a new application context instance. It's a foo class reference in Kotlin, and it's a register bean for bar. But where's the bar argument, right? No bar argument here. We're actually calling a Kotlin extension here. In many ways, we even call it a Kotlin extension up there, but many methods that you can call from Kotlin are actual Java methods that just match nicely and you don't even notice. But what we're using here is a generic application context extension that we're shipping in the standard Spring context jar. Just grab it from Maven Central, Spring context 505.jar, the Kotlin extension is in there and you don't even notice. But the Kotlin compiler notices it. It understands there's a generic application context extensions.kt file. And automatically, whenever you use generic application context from a file of yours, right, from a Kotlin source file of yours, the Kotlin compiler understands that it has the Java methods in generic application context, and it also gets those extra methods from the extensions file that are defined in a Kotlin extension syntax. It's a little bit like default methods, or like in Groovy, you know, declaring additional methods for existing classes, a kind of similar model. That Kotlin supports out of the box, and that's a really great feature. It allows us to do what we do here, that Kotlin comes with this kind of extension model. So back to the actual example, what we do here is that we pass in a Kotlin function that creates a new bar instance. And just like in the version before, this is sort of a callback, right? It's not a Java 8 Lambda expression, it's a Kotlin function, but it does the same job. It is essentially an instance supplier function, right? But there's no need to specify the component type separately. The only need for this, the only reason why this is needed, is that a Java 8 Lambda expression does not allow for determining which return type it actually has at runtime. Of course, it's quite clear when you read the source code, but at runtime, a Lambda expression is something quite abstract, and we cannot reliably obtain its return type. So we insist on repeating kind of that return type as a separate argument. A Kotlin function is compiled differently by the Kotlin compiler, and there's a runtime sort of reflection API that Kotlin comes with that we're using here that allows us to reliably obtain the return type, so no need for repeating the register component type if you don't want to. If there is no specific difference, I mean, there's always special cases, right? So in both cases, of course, which I haven't mentioned before, bar depends on foo, right? So we need a reference to foo, constructor injection basically, and in both cases we simply call back to the container. We use programmatic retrieval APIs in order to obtain the instance when actually needed, and here we actually have kind of a function where the context is passed in, so the context is just it in the Kotlin function. You can call the more in a pure function style, you can call the passed in context that way. The version below is kind of an interesting syntactic spin, a little alien for the average Java eye, also quite alien for my own eyes usually. But these are variants that Kotlin easily allows for. And now by using a different type nomination syntax and a slightly different invocation style in that we call the register bean methods within the scope of the containing CTX declaration, no need to kind of call the methods on a given variable that way. So there are some quite nice variants here. And this can also be used to create a sort of creation DSL, right? According to your decisions on how you're using this, a DSL-like experience might follow. These extensions are actually quite simple. An important point from my implementer side is that we get these features without much effort. We are shipping a few quite simple and straightforward extensions, and all of a sudden, a lot of nice Kotlin, idiomatic Kotlin variants emerge out of it. That's a great feature to value or effort to value ratio. All right, so much for the component style discussion. Some of this is going to sort of re-emerge a little because it connects really nicely with reactive architectures. Functional programming and or functional invocation style and reactive architectures go together very nicely. So we can't go into too much detail, and it has been discussed in other talks. Just a quick motivation why we even care. A couple of years back, there has been the so-called Reactive Manifesto. Not that I'm a great fan of manifestos myself, but they get a few important points really right. We care about responsiveness and resiliency in particular in highly loaded web architectures. Imagine a larger web system, or just a microservice with a couple of HTTP endpoints, and unusual or even extreme load scenarios. Unexpected peaks, many small requests, while some requests take really long to arrive at an answer, others might be very quick to reply to, very uneven request processing times. And of course, in a standard servlet architecture, there's a bit of a limit to what you can arrive at, right? I mean, a servlet-based stack, like a Tomcat Jetty setup, can be fine-tuned, customized in terms of its setup very nicely. It can perfectly be good enough for many, many scenarios. There's nothing wrong with a highly tuned servlet stack. But it has its limits. It has certain things that it really, out of the architecture, cannot be good at. There's a maximum number of threads that you can register in a servlet container. If you arrive at that number of threads, your servlet container basically is exhausted, right? Your HTTP endpoints are not going to accept newly incoming requests, newly incoming connections. So if you have 150 threads in that servlet container thread pool, and they are all busy, there is no thread left to process this little index HTML request that's coming on next, even if that would be trivial to reply to. So servlet stacks have their issues. There are ways, of course, to deal with this, no doubt about that, right? But there's also a completely different kind of web architecture that directly addresses those kinds of scenarios. That's what we mean by a reactive web architecture. Instead of using blocking I/O operations in a thread-bound servlet invocation, we turn it all around and use an event loop-based model with asynchronous streams, asynchronous I/O, even back pressure-driven I/O, where we understand there's only so much data we can produce that can actually be passed on. Let's not block and pump too much data towards the response if there's currently network suggestion and we cannot pass that data on anyway. So it's also putting some pressure off the buffers in the system. The underlying model is called Reactive Streams. Reactive Streams is an effort that kind of grew out of the Reactive Manifesto, lives on reactivestreams.org, which is also what our Project Reactor is based on. Project Reactor is kind of the core of Spring 5 reactive stacks. Project Reactor is run by a group at Pivotal, kind of in the same group that I'm in. And Project Reactor is essentially a kind of tightened up variant of RxJava. It is a reactive kernel, but reactive streams based and Java 8 based from day one, in that sense differing from RxJava, even differing from RxJava 2, which still is Java 6 compatible because of its Android user base. So Reactor is really a tight Java 8 based, reactive streams based, server oriented reactive kernel built on reactive streams. So in a nutshell, reactive streams models a very simple interaction. A publisher may send data to a subscriber, but the subscriber is in charge. The subscriber asks, requests certain data elements from the publisher as it is able to actually process them and pass them on. So a publisher may be particular access a result of a particular query from a data store. The subscriber may be an HTTP response. It doesn't make sense for the data store to publish the data if the subscriber cannot pass it on. And if the subscriber is not ready to write any data, it wouldn't even ask the publisher to start its business, right? And if the publisher takes a while, and it takes a while to actually execute the query, the subscriber doesn't block any thread. It just sits registered with the event loop to be called back once the publisher is actually able to produce the next element, which is in particular important for data store interactions or for interactions with other network streams. Like the publisher may also be, of course, the result of an HTTP request to some other microservice, for example. So this is a very fundamental model. This is actually pretty deep underneath the covers. You don't need to code against reactive streams. You're coding against a higher level reactive composition API, like Reactor's Flux and Mono, or like RxJava's Flowable, for example. So this is just happening underneath the covers if all the infrastructure components actually comply with reactive streams. So it would be nice if your data store driver, for example, would be reactive streams compatible or at least adaptable to reactive streams. Otherwise, you're in trouble. In a reactive architecture, you need non-blocking interaction all the way, from top to bottom, from the incoming HTTP request down to the data store and back up. There needs to be non-blocking interaction. And we'll get to the kind of, we'll follow up just in a moment on these consequences. So to be very clear here, in Spring Framework 5, there is actually a choice of web stacks. There are two stacks living next to each other. There's Spring MVC and there's Spring WebFlux, or Spring Web MVC as we actually call it in Spring WebFlux. Spring MVC is servlet API based, as it always was, and running on a servlet container. The servlet API is shining through here. It's actually the foundation for it, right? So a Spring MVC controller can declare an HTTP servlet request or HTTP servlet response argument. It can very directly interact with the servlet API, but more importantly even, the entire abstraction is servlet API based. Invocation semantics are the servlet semantics you are invoked within a servlet container thread for the given request. You're reading from the request, you're writing to the response. All of those are blocking operations within the servlet container thread. When you're done writing the response, the thread goes back to the pool. This is particularly important because an existing Spring MVC application can be easily upgraded to Spring Framework 5, because there's Spring Web MVC. It's of course an updated version of Spring Web MVC, but it's fundamentally adhering to the same semantics, to the same contracts. It comes with the same SPIs. All existing extensions still work. Your existing code still works without modifications. In parallel to that, we have Spring WebFlux as a kind of alternative web stack, technically a separate module, Spring-WebFlux, a new module in Spring Framework 5, which shares some commonalities with Spring MVC, in particular some common design, but runs on a totally different foundation. A Reactive Streams-based web foundation that we ship in Spring Framework 5. It's based on the Reactive Streams APIs, and it's based on Project Reactor internally. And there's a choice of underlying servers that you may run on. You may choose to use Netty, kind of everybody's favorite, most powerful networking stack in existence out there, an extremely powerful but also somewhat complex to configure a web stack. So Netty is, of course, not servlet-based at all. It's a fundamentally asynchronous HTTP kernel if you want to use it for HTTP purposes. And this is a key reference that we allow to run WebFlux-based code on. Alternatively, you may also use Tomcat Jetty, Undertow Core, technically even other servlet containers, but we primarily focus on Tomcat Jetty and Undertow. So what's with that, right? Well, it's quite simple. Down here, we support any Servlet 3.1 container through the Servlet 3.1 async I/O model. But that's internal adaptation. The Servlet API does not shine through here. We essentially don't care that those are servlet containers. We're using them as HTTP engines. We're taking their async I/O capabilities that have been introduced in Servlet 3.1, but basically nobody uses them in a regular servlet app because they are really a different mode of operation for the container. And we're exactly using those totally different facilities to adapt Reactive Streams onto them. Tomcat and Jetty are particularly fine candidates. Undertow Core as well, because Undertow Core is actually, Undertow is the server behind, the HTTP server behind Wildfly, and Undertow Core does not have any servlet capabilities. So we are really going straight to the HTTP engine there. No servlet layer even on your class path 10. Right, and WebFlux runs on top. So there's a lot of commonality as mentioned, right? There's an annotation-based component model that can be used by both. There's a new Reactive Web Client API that can be used by both. Both stacks can run on Tomcat Jetty or Undertow. But of course, it's an either-or choice. You're not mixing and matching the setup. Tomcat or Jetty, they run either in traditional servlet mode or in their reactive mode. So if you want to mix and match, you can do that at the architectural level by having one microservice implemented as a traditional servlet web stack and some other as a reactive web stack. That's okay, but a particular service, a particular HTTP engine on a given JVM needs to be one or the other. Any kind of blocking operations are not a problem in Spring MVC because in a servlet container world, that's totally normal, right? That's what the model has been designed for. This kind of imperative logic against blocking I/O. If you're using a data store driver without any async capabilities like JDBC, JPA, you're better off in that world, right? Frankly, for newly written code, don't even think about it too much. Don't bother with worker thread pools over here. Just stick in that world. That really goes nicely together. But if you happen to have an asynchronous driver for Postgres, for Mongo, for Redis, for some other data stores, and you want to expose the power that that reactive driver brings through your web application to the HTTP endpoints, then Spring WebFlux is your friend. And Netty, of course, is the most powerful option, but you may also run on Tomcat and Jetty. A lot of work went into Tomcat 8.5 and 9 to make it better suitable as a reactive HTTP engine in this context. And here we run in an event loop, as mentioned before, a Reactive Streams-based event loop. So there's a small number of threads serving a potentially very high number of connections, of clients, very efficiently. So this is a totally different mode of operation with different tuning characteristics, but quite clever tuning characteristics, as long as you adhere to its rules. No blocking over here. So you need to code against the reactive APIs exclusively. So what does this look like? Well, quite simple. In the annotation-based world, initially, it looks like a regular class. It's annotated with a controller. It has mappings on methods. But what about the signatures of those methods, right? Well, they're still flexible for the incoming part, for the incoming parameters. But what about here, right? There's a new model appearing for the return types. There are mono and flux. Those are the core reactive composition APIs. Mono kind of representing the recipe to arrive at a single element or none. And flux is basically an open-ended string of elements that you may arrive at. These are sort of reactive versions of Java util optional and a Java util stream. Or if you talk about our Java APIs, this would be like a single, this would be a flowable. So those methods do not actually load the data. They return a recipe for arriving at the data when needed. So they immediately return, they don't block. So like if a get users call comes in, we assume we have a repository coded against the reactive data store driver underneath. We call find all. We get a recipe back for how to arrive at all those elements for the given repository whenever we are able to produce the to pass on the outcome, right? So it's up to the runtime engine, up to the Reactive Streams engine at runtime to determine when we actually trigger production of those elements and pass them on to the HTTP response. So it's a quite different programming model. It's very similar to RxJava. If you ever encountered RxJava code, you can reuse your know-how from there right here. A little more challenging is what we call the functional Web Endpoint API. So this is kind of a common part, right? A reactive web controller is basically a regular Spring MVC controller adhering to reactive processing semantics in the endpoint methods. And to some degree, some of this is even supported on regular servlet containers as far as possible. There are certain things we can do even in a regular servlet setup for asynchronous response handling, and we even have a little bit of support for those things over there. But fundamentally, this is a different way of thinking about your web endpoint methods in the annotation-based world. And it is even clearer over here. In the functional world, you're essentially saying there are no annotations, there is no blocking model for anything. I just build functions that are capable of producing HTTP responses whenever corresponding requests come in. I'm implementing handler functions that basically take an incoming request, extract some metadata out of it, convert it as necessary, pass it on to the next component, like to the aforeseen repository method, and whenever this is actually needed, we can trigger this sequence of operations, this chain of operations. And finally, we're saying, if everything is fine, server responds this status code, and here's the Reactive Streams publisher that allows us to arrive at the body. Mono and Flux are technically Reactive Streams publishers, so we can pass them on as needed, and at runtime, they are going right into the Reactive Streams-based event loop as publishers. So this is essentially doing the same thing as these methods here, but it's stylistically different, because those methods have to comply with the handler function signature. There is no reflection here. There is no annotation-based discovery and adaptability of parameters. There's a fixed incoming parameter and a fixed return type, and you programmatically code to get from the incoming request to the desired response. And here, up here, we see the router function that says, basically, incoming request, a predicate that matches this request. Whenever this predicate matches, dispatch to this handler method. And whenever the other predicate matches, go to the other handler method. So this is modeling the same logic as here. Way more powerful, but also a little more elaborate because it's totally programmatic, no reflective dispatching. It might look a little less alien if you structure it like this. This is just a minor restructuring. Instead of the extracted handler function compliant methods, we have inline lambda expressions, which is way nicer to DI if you look at it for just 2, 3, 4, 5 maybe endpoints. But if the number of endpoints grows, you're probably better off decomposing it into extracted methods, or depending on how complex your logic is inside, right? So again, router function, incoming routes, this predicate matching, this inline lambda handler function, taking the request and producing a recipe, a Reactive Streams publisher for arriving at the response, immediately returning it, leaving it up to the runtime event loop to actually trigger processing. So functional style basically connecting to reactive web architectures is really what Spring Framework 5 is about in terms of its core themes. But once again, it's an option. We have a servlet-based stack and a reactive-based stack, an event loop-based stack. Choice of yours for the server side, right? But we also have a new async, or actually reactive web client. And that web client API uses the same API types. So we also have a client-side API that is modeled according to the same design style, uses the reactor types by default. So you can code the same way on the client side of the HTTP interaction. Or in particular, if you think about microservices, there might of course be a facade service being a Webflux-based server stack, using the web client API to call another service within your system. And then, of course, this goes together really nicely. You call that other service, you get a Reactive Streams publisher, in this case a mono or Flux from Reactor, and imagine you're in that world. You can just pass it in here. Right? The outcome from the reactive web client can be transformed a little or even taken directly and baked into the response for the service that is calling you. So we actually provide all the pieces for a, well, comprehensive reactive web architecture across multiple services, across multiple HTTP servers in a microservice layout, for example. All right, you can follow up on the details. There's a lot of coverage out there. There's a great article on InfoQ by my peer, Rosen Stoyanchev, quite extensive, explaining many of these things in a little more detail and from a slightly different perspective still. And there's plenty of tutorials on how to combine these features and how, for example, the reactive web clients can, under certain conditions, even be used in Spring MVC endpoints in a few places next to regular blocking I/O operations in other endpoints. So there's even, again, many shades of gray, quite a bit of combining those features in interesting ways. So those are the two highlights, right? The two central elements in Spring Framework 5. I'd like to use the remaining few minutes to run you through a few little things that we usually don't mention that much, or at least not mention so exclusively. I've already hinted at nullability. We declare nullability annotations across the entire Spring code base now. We do this in particular for nice interaction with the Kotlin compiler, because if the Kotlin compiler sees clear nullability declarations, like an incoming parameter is allowed to be null or not, an outgoing return type, return value can be null or not. If there's a clear definition for this, the Kotlin compiler allows assignments to non-null variable declarations in Kotlin. Whereas for standard Java APIs, where it's like a little unclear on whether that can ever be null, you need to be on the defensive end in Kotlin and always allow nullability. We do this across the code base. You may imagine this took revisions of like 1,000+ source files. We do this very consistently, and we use IntelliJ ideas, constant conditions and exceptions in inspection to actually validate that we do it the right way, that the logic actually adheres to the nullability declarations. So great support in IntelliJ idea there. It really allowed us to do this, to take a large existing framework code base and add a clean nullability declarations through nullable annotations across the entire code base and to validate that we got it right. This is an example that I've shown yesterday. I'd just like to show it in a slightly different way to illustrate the nullability, right? This is the Object Provider API, which has a few nice little methods using Java-util function, as discussed yesterday. The standard methods, getIfAvailable and getIfUnique, have also been revised. They are nullable now, whereas the methods down here are not nullable, and we have a non-null by default rule in the Spring codebase. Because if you have a default supplier, the outcome is never null, right? It's either there, then you get it. If it's not there, you get the default created by the default supplier. No null value here. Whereas if there's no default supplier, there may be a null value down here, right? So that is nullable. So this also goes really nicely together with the Java 8 functional API style, because in functional APIs, null is really a little the odd one out. You're trying to avoid it, and you're trying to be very clear about whether something can be null or not, and usually it shouldn't. So even the Spring APIs, and this shows in the Java doc and in the source files, of course, have a very clear indication of what you can expect from them. It goes really nicely with some of the new overloaded methods. We have, again, a little bit Kotlin-inspired support for data class binding. This, of course, works both in Spring MVC and in Webflux. Try to use it, right? It's quite intuitive to use. Instead of setup-based beam property bindings or direct field bindings on mutable instances, try to define data classes in Kotlin, or maybe Lombok is your friend. Use the data class model in Lombok. Immutable objects populated through a constructor, Spring's data binding automatically adapts if it sees that there is an immutable object without setters and a single primary constructor. Then we automatically switch to data class binding mode. This works really nicely. Can be fine-tuned as needed, in particular in terms of the parameter names, because the parameter names are really significant here for that kind of constructor. They match the incoming data structure, and the elements are extracted along those lines. So long requested, goes really nicely with Kotlin, goes nicely with Lombok as well, and it's even quite nice to use in standard Java. So a few very minor ones to wrap it up. We revisited the entire API surface in Spring. So also some lower level stuff, like the task scheduler, for example. A task scheduler interface can be used programmatically. There is the addScheduled method, the addScheduled annotation. Instead of that, you would, in a more functional world or for more dynamic or more complex tasks, you would use a task scheduler, inject it, and call schedule methods on it. No news really, they existed before. But there are nice overloaded methods now, integrating with java.time, having a little bit more monitoring, integrating with the completable future API with direct adaptability to completion stages or completable futures. So this also saw some significant revisions in Spring Framework 5. If you're already using some of this, you might appreciate the integration options here. So, and now, actually there is a remaining slide that I currently cannot go to, but we're somewhat at the end of the line anyway, so I'll tell the wrap-up in my own words. I think it is actually frozen if you look at the arrow. That doesn't look good, does it? A few words towards Spring Framework 5.1. This is essentially what we have in Spring Framework 5.0 already. In 5.1, we are upgrading a few things. We are upgrading to Reactor Core 3.2. Interesting, nice stuff in Flux and Mono coming in Reactor 3.2 that we immediately base Spring Framework 5.1's Webflux story on. We have, of course, a JDK 11 story, as mentioned yesterday. So Spring Framework 5.1 tracks JDK 11 and allows for composing new Spring-based applications, not only for execution on a JVM 11, but also with the use of JVM 11 source and targets, right? And this involves an ASM upgrade. It involves the use of Spring on the module path on a JVM 11, which is yet another topic where we need to revise a few things, in particular our runtime class generation fallbacks. So there's quite a bit of work that really wraps up everything we're doing here in Spring Framework 5 for the latest infrastructure. We're also waiting for RxJava 2.2 to materialize. We were originally waiting for a netty upgrade. That's probably not happening in that time frame. So that you get a completely up-to-date JDK 11 compatible and using the latest networking stack underneath the covers, a Spring Framework 5.1 in at least early September this year, hopefully even a little bit earlier than that. We are going to keep up that rhythm, but there's no specific plans for what we're working on next. So I can guarantee you there's going to be a Spring Framework 5.2, and it's going to come in 2019, probably in the same rhythm again. But first things first, I personally will be really happy once JDK 11 is out, once all our work for JDK 11 compatibility happened. I find Reactive 3.2 really important. It's already in its milestone phase. There are a few things I'm really looking forward to wrap up, completing the mission that we're on in Spring Framework 5 here, and allowing you to build the best possible modern-day web stacks on top of the frameworks and framework combinations that we provide here. So thanks for your attention. Sorry that it actually hangs here, but I hope the summary in words was equally okay as when visually seeing it. The discussion zone is open, right? So yes. I'll be there just as long as it takes me to get over there. Thanks for your attention so far, and enjoy the closing.
Thank you very much.